Here's another airplane wind problem. So let's first sketch the picture of what's going on. So I have here an airplane that has an airspeed of 500 kilometers per hour bearing north 45 degrees east. So north is going up, east is going to the right, right there. Here's my plane, 45 degrees, and that's 500 kilometers per hour. Then I have a wind whose velocity is 60 kilometers per hour in the direction north again, but this time going left-west, 30 degrees west. And that speed was 60 for the wind. Okay, so we're going to set up our chart. We have our plane, we have our wind. Remember the formula? We're taking the magnitude and multiplying it by the angle that's formed, cosine theta I, sine theta j. So for each of these, I'm setting up a chart just to make life easy and separate. So the first column is going to be the magnitude times the cosine of the angle. So for the plane, the magnitude is 500 cosine. Now remember what I said, we always want the angle in respect to the positive x-axis, so we're looking at the angle that's going down right there to the positive x-axis. That's 45 degrees left. And then we also set up the column for the magnitude times the sine of the angle. So that's going to be 500 sine and 45 j. Okay, the wind, the magnitude is 60. Now let's take a look at the angle that's formed there. I'll do that in green. We got 30 degrees plus another 90, so that's 120 degrees that it forms with the positive x-axis. So I have 60 times the cosine 120i, and then I have 60 times the sine of 120j. Alright, we need to use our calculators and multiply each of those. Okay, so I figured all four of those out in the calculator there. This one and this one, this one and this one. Now I need to consider them because the wind is affecting the plane, so if I need to add those two vectors together now. And there's the result that I get for the plane plus the wind together as a vector. Alright, we want to know the speed of the ground speed of the plane, so that's finding the magnitude. So the magnitude formula is taking my a, squaring it, taking my b and squaring it. So my a here is the one in front of the I, so 323.6 squared, plus my b is the one in front of the j, 405.6 squared. And I get it to be 518.9 kilometers per hour as my ground speed for the plane. Now I need to find the direction angle, the direction. Alright, so that formula is tangent theta, my sine divided by my cosine. Well, my sine is the one that's in front of my j, so that's 405.6 divided by my cosine, 323.6. And then don't forget to get the angle, I need to do inverse tangent, so I get my answer to be 51.4 degrees. Alright, now let's look back up at our picture here. Our plane is in quadrant 1. The wind is being affected going in quadrant 2, so it does make sense that the resultant direction would be in quadrant 1 also. Tangent is positive there, so that's north 51.4 degrees east. That's my direction of the plane.